So this problem says that we have tau equals I alpha for an object rotating about a fixed axis, where tau is the net torque acting on it, I is the rotational inertia, and alpha is the angular acceleration. This expression does what? Does it define the torque? Does it define the rotational inertia? Does it define angular acceleration? Follow directly from Newton's second law, or depends on principle of physics that is unrelated to Newton's second law? Okay, well, let's take these one at a time. Definition of torque. Well, the definition of torque is equal to d cross F. How do we get a torque? We have a force at a distance. We multiply the two using a cross product. So A, as I have it defined, is wrong because the definition of torque is something different. Same thing with the moment of inertia. The moment of inertia is we look at each individual mass and we ask how far away is it from the rotation axes. We square that number, multiply by the mass, and then add up all of those little moment of inertia terms. So each mass has its own moment of inertia. We add up all those moment of inertia terms, and this is how we get it. So this is how we figure out moments or rotational inertia or moment of inertia. Well, the definition of angular acceleration. Angular acceleration is defined as how fast the angular velocity changes, which we can write as d omega dt. And it is a vector equation. Our change of omega in a change of time, or d omega dt if you like the vector or the calculus version of this. So C is wrong. Well, I know that this equation, I actually prefer a different equation for this one. I prefer to write it as sigma tau is equal to I alpha. My net torque, I add up all my torques, it gives me I alpha. Well, this looks really similar to MA. F equals MA. So the correct answer is D. We followed directly from Newton's second law. We can change these values or use these values to figure out how each part of our solid body is rotating. So, not that hard of a question, but it's good to see that these are the definitions. This is actually how we use these quantities together. So Newton's second law, or Newton's second law for rotation, tells us how to add up some quantities and give rise to either an angular acceleration or a regular acceleration. So a net torque gives us an angular acceleration, a net force gives us a regular acceleration, and they have a proportionality constant that's related to how hard is it to rotate that object, its inertia, its mass, or its moment of inertia.